Dive into the cutting-edge realm of artificial intelligence with this comprehensive video course on Google's AI model, Gemini. Guided by Anya Kubo, this course will teach you how to use the Gemini API and how to build an AI chatbot powered by Gemini.
If you are new to the world of AI, this is the perfect video for you. My name is Anya Kubo and I'm a software developer as well as course creator here on Free Codecamp as well as on my own channel. In this video course, we will be learning about AI as developers through the use of Google's AI model, Gemini. Now, as some of you may or may not know, we can use AI chatbots in order to ask questions about the world, generate images, or even have full-on chat using information we fed in before. But how does this even happen? And how can I build my own AI chatbot? Well, this is exactly what we'll be covering today. In fact, here is a full list of what we will be looking at throughout this video. We will start off with this introduction and then move on to have a look at what Gemini actually is, followed by looking at AI so that we actually understand it. Next, we will look at LLMs or large language models, followed by getting our API key in prep for making out our final project. We will then quickly cover tokenization before moving on to some of the models that we can access with Gemini. And then, of course, we're going to build out our AI code buddy. So, what are we waiting for? Let's do it. What is Gemini? In the least amount of words, Gemini is a series of multimodal generative AI models developed by Google. Gemini models can accept text and image in prompts, depending on what model variation you choose, and output text responses. What this means is that we can feed in text prompts, such as what day of the week is it today, and we can receive responses back, such as it is Wednesday. And not only that, we can feed in images as prompts too. So I can feed in a picture of a cat in a hat, and we can ask what is in the photo, and we should receive back a text response. Pretty cool, right? We can do this by interacting with the Gemini app, previously known as Bard. We can do so pretty easily by typing the prompt here, and we can then even see a history of all our previous chats. So here I am writing a prompt in text and receiving the text back, as well as continuing a whole chat that takes into account the previous messages I sent. Or here I am uploading images and asking questions about them. Or if you actually want to use this cool technology to build your own apps, you can also interact with the Gemini API. By interacting with the API or Application Programming Interface, we can do exactly what the Gemini app UI does. So for example, putting in text inputs and receiving a text input back by using the Gemini Pro model and the Generate Content method from it. And we can also use the Generate Content method from the Gemini Pro Vision model in order to prompt with text and/or images and receive text back, as well as build multi-turn conversations with the Gemini Pro model using the Generate Content method as well as some extra configuration. We will also look at creating embeddings using the Embedding 001 model with the Embed Content method, but for that we need to understand what embeddings actually are first. We will go into these models and the methods they come with and how to use them individually later on. Just for now, know that these are the most popular at the time of recording and a few more do exist, but we will not be covering them in this particular course. Okay, so we got it? To recap, Gemini is a series of multimodal generative AI models developed by Google that you can interact with via an API or via the app of the same name of Gemini. What is AI? AI, or artificial intelligence, is the simulation of human intelligent processes by machines. I say simulation as artificial intelligence is not sentient, at least not yet anyways, meaning it cannot think for itself as much as it may seem it does. Often when we say AI, we most of the time are referring to a term called machine learning. Machine learning works by using large amounts of training data that is then analyzed for correlations and patterns. These patterns are then used to predict outcomes based on the training data provided. So, for example, if I was to feed this training data, basically summarizing what each paragraph is about, so for example, that we are feeding data saying that a paragraph that looks like this should be categorized as finance. The second paragraph should be put in the category of fashion, and so on. With some code, we should be able to train our AI model to correctly guess what future paragraphs are about. And that's it. So if we were to get a paragraph that says Bad Bunny had some black Adidas sneakers that were from fall 2022, this was a great something something, then thanks to our training data, the AI model should guess with some percentage of accuracy that the topic for this paragraph should be fashion. Of course, that is a super basic example, and we would need way more data than these 5 paragraphs right here, but you get the idea. As of now, rapidly improving generative AI techniques can create realistic text responses and even images, music, and other media, thanks to the huge amounts of training data and talented developers working on it today. Large language models. Large language models, or LLMs, are machine learning models, sometimes referred to as AI models, that can comprehend and generate human language text. So, in fact, we already had a look at a super basic example of one. It was when we fed training data into our AI model so that it could accurately predict what category a paragraph would belong to. At their most basic level, large language models are like sophisticated autocomplete applications. Just like guessing a category that a paragraph can belong to, we can train models to take an input of text, such as "you can lead a horse to water," and have the LLM output text statistically return "but you can't make it drink," as the following text suggestion based on patterns learned from the training data. In fact, you can use this basic property of LLMs for various applications. You can use it to generate poetry, short stories, metaphors, blog posts, and other creative copy, or convert structured data to free-form text, or even extract and summarize information from free-form text, generate code, translate, or build a chatbot like we will be doing today. So now some of you may ask, is there a randomness in LLM responses, or are they deterministic? The short answer is yes to both. When you prompt an LLM, its text response is generated in 2 stages. In the first stage, the LLM processes the input prompt and generates a probability distribution over possible tokens or words that are likely to come next. For example, if you prompt with the input text, "The dog jumped over the ... the LLM will produce an array of probable next words. So, as you can see here, the word fence has the highest probability score as opposed to ledge or blanket. This process is deterministic. An LLM will produce the same distribution every time it's input the same prompt text. In the second stage, the LLM converts these distributions into actual text responses through one of several decoding strategies. A simple decoding strategy might select the most likely token at every time step. This process would always be deterministic. However, you could instead choose to generate a response by randomly sampling over the distribution returned by the model. This process would be random. You can control the degree of randomness allowed in this decoding process by setting the temperature. A temperature of 0 means only the most likely tokens are selected and there's no randomness. Conversely, a high temperature injects a high degree of randomness into the tokens selected by the model, leading to more unexpected, surprising model responses. Okay, so now that we've understood that, let's work on actually getting our API key to work with Gemini. Just like most APIs, the Gemini API uses API keys for authentication. In this section, I'm going to show you how to get your own API key for when it comes to communicating with the API from the applications that we will be building today. Remember, make sure not to share or upload your API key anywhere public. If you do, someone might take it, use it in their own project, and use up all of your free tokens or rack up a huge credit card bill if you have a card attached. This also includes exposing it in any client-side code. By this, I mean building an app without a backend and deploying it onto the internet. The code in this case will be visible simply by inspecting it like so. Someone will then be able to go and take it from here for their own use. To use this key safely, requests must be routed through your own backend server where your API key can be securely loaded from an environment variable or key management service. Okay, so let's do it. Let's get our API key. Okay, so first we're just going to start off on this URL. Currently at the time of recording, this is what it is. And we're going to choose to build with Gemini, which just take us here. And then we're going to click on AI Google.dev. Now you might be required to sign in, or because I am using Google Chrome, I could just go ahead and get API key in Google AI Studio. So I'm just going to click here and ta-da! Once you are here, so essentially you can write prompts here if you would like, such as what day is it? And hit enter, and the chat will work. You can actually select the model from a drop down here, and you can also select the temperature. The temperature is something that we covered in the previous section, and essentially, as we know, allows us to be more deterministic with our answers. So that is something that you can set. You can be more deterministic or less deterministic. Okay, so we get the response back. Great. Now to get your API key, all you're going to do is click here. So I'm going to go ahead and select that, and we're going to create an API key. So go ahead and select create API key, and I'm just going to search for generative language client. It's actually the only Google Cloud project that we have, and go ahead and select create API key in existing project. So now we have our API key. Make sure to copy this and of course keep it safe, and do not share it or put it in any code that can be visible to anyone on the internet. Okay, cool. That is just because you could use up all your credits, or if you have a credit card attached, it could of course take up all your pennies from your credit card. Amazing. And of course you can delete API keys and create new ones if you want. So for example, if one is compromised. And that's it. I hope that was easy to understand. Great. Now that we have our API keys, let's get to looking at the available models to our disposal after learning about tokenization. When using long prompts, it might be useful to count tokens before sending any content to the model. If you want to be specific about it, you can use one of the models at our disposal. It is the Gemini Pro model we touched on previously, along with the count tokens method. You can get it with this call command. I will show you how to do this in a bit. However, as a general rule of thumb for Gemini models, a token is equivalent to about 4 characters. 100 tokens are about 60 to 80 English words. Okay, so let's do it. Okay, so all I'm going to do in order to get a template for the code is head over to the REST API, and then I'm going to just go to count tokens, and this will tell me the method that we're going to use from the model, the Gemini Pro model. So we're going to use this in order to write our own curl command. So let's go ahead and get our terminal. I'm going to write curl just like so. As the header content type, we're going to have application JSON. And then as the content, we're going to have this object, which takes an array of another object, and then the text that we want to essentially find out how many tokens make it up. So as the text, I'm just going to write, let's go ahead and go up there. Let's do write a story about a magic backpack. And then we're going to have to put in our API keys. So making sure that this is the same. So generative language, googleapis.com/v1 beta models, Gemini Pro, and then the method count tokens. And then we're going to put in our API key here that we just saved. So go ahead and just whack in your own like so and hit enter. And amazing. So we now know that this string takes up 8 tokens. Great. And that's it. Models. As we know, we can interact with the Gemini API. By interacting with the API, we get access to all the Gemini generative AI models and their methods, including these popular 4 right here. As a recap, we can have text-only input and use the generate content method to generate a response from the Gemini Pro model given an input message. And we can also use the generate content method from the Gemini Pro Vision model in order to prompt with text and/or images and receive text back. as well as build multi-turn conversations with the Gemini Pro model using the generate content method, as well as some extra configuration. We will also look at creating embeddings using the embedding 001 model with the embed content method, but for that we need to understand what embeddings actually are first. So let's have a look at how these four work. For this course, we will be using Node.js. Make sure to have Node.js version 18 and above installed and npm installed. First off, we would need to initialize the generative AI model. We would need to do this for all the scenarios. In order for this to work, you will need to install the SDK package right here. Okay, so here is the code we will be using to initialize the generative model. If you want to have a look at it, this time we're going to be going to Node.js as we're going to start building out a Node.js app. So let's go ahead and do it. We're going to initialize the generative model after, of course, installing this package. So let's get up our code editors of choice. I'm just going to create a new project. I'm just going to call this Scratchpad. Okay, so just like that, and create it. So here we are as an empty project, and I'm just going to get up my terminal. So I'm going to click here, making sure that we are in the Scratchpad, and I'm just going to initialize this. So npm init for this to essentially spin up a package JSON file with the correct configuration. So let's go ahead and choose package name default, version 1, description I'm going to keep empty. I'm just going to literally go through all of these and choose the defaults. Is this okay? And yes. And my package JSON file should be in here now. Great. Now let's go ahead and install that dependency. So I'm just going to go back in here. Let's copy that. And I'm going to do npm install Google Generative AI. So please be aware of the version of this package that we will be using for this tutorial. If you are using this in the future and something isn't working, it could be down to the version you are using, in which case you'll have to revert back to this. So for example, if it's here, just go back to this and then run npm I again to install this package. But of course, we don't need to do that because this is the version that we want to use for this project. Great. Now, while we are here, I'm just also going to write a start script. So start and node. We're going to listen out to changes on an index.js file. That is fine. If we want to listen out to constant changes, we can use nodemon, in which case we need to install the package nodemon too. And once that is done, we should be able to use a start script. So this is the script I just wrote, to essentially run an index.js file and listen out to changes on it. So let's go ahead and create that index.js file. So it's a JavaScript file. I'm going to call it index.js, just like so. Wonderful. So this is looking good. I'm happy with all of this. Let's just shut this down now. Okay, I'm going to make this a little bit bigger for you. So now I can use npm run start, and this will start off listening out to the index.js file. That is good. And now we're going to essentially initialize the generative model. So let's go ahead and do this const, and we're going to get Google Generative AI from Google Generative AI. Okay, so that's how you need to write it. And maybe let's just minimize these for now. So great, once you have that, we're going to get Google Generative AI. We're going to pass your API key into it. Okay, so we're going to pass it through so that we can use Google Generative AI. For the purpose of this tutorial, I'm just going to pass in the API key like so. And now we have all of its method and properties to our disposal. So let's save them as something. I'm going to save them as Gen AI. Great. Now, if you do want to be super safe and you don't kind of even want to leave your API key, even in here for demo purposes, you can create a env file. So you would just go ahead and create a new file, call it .env, and this is essentially for secrets. So I'm going to call this API key and just paste in my API key. In order to access this, so this value by its property, I can now just use process env and then API key. Okay, however, we do need a package for this, so let's go ahead and do that. I'm just going to open it up again, making sure that we are in Scratchpad, and we need to install a package called .env so that we can use .env, okay, in this project. And of course, we need to also require it. So require .env config. Great. So let's get rid of that for now, and this is still running. Wonderful. So that is now doing its thing. We've initialized the generative model so that we can now, like I said, get all the methods and properties from it. They're all stored under Gen AI. So I grab Gen AI, and for example, I can use get generative model, and we can pick which model we want. So for example, I could go ahead and put model, and then we would put Gemini Pro or anything like that. Okay, so we're going to put in the string of Gemini Pro, and then let's also save this to the const model, as that is the model we will be using for this tutorial. Wonderful. So that is it. Of course, if you need to change the model, please go ahead and change the text here, making sure that it is spelled exactly the same as in the documentation, meaning that if you want Gemini Pro Vision, it has to be spelled like this. Or if there's any more in the future that you want to use, just again, refer to the documentation to get that spelling correct. Wonderful. Let's move on. This is the final code. Okay, so just to make sure this works, I'm just going to console log out the model. And great. Everything looks as if it's working well. Okay, so now let's move on and work on the generating text from text only input. When the prompt input includes only text, okay, we just want text, we want a text prompt, and we want some text returned back to us from the model. For that, we need to use the Gemini Pro model with the generate context method. Okay, so that's what we're going to be doing next. I'm going to show you how to do it. So this, I would say, is the most basic one. I would, of course, need to initialize the model. So let's go back to where we left off. So here we are where we left off. I'm just going to get rid of this console log. Once again, this is me initializing the model so I can use it. And once we have done that, perhaps let's go ahead and write a function for this. So I'm going to make this an async function. Let's call it run, just like so. And in this function is actually where I'm going to define what model we want to use. So I'm just going to whack that in there like so. The model is going to be Gemini Pro, as we said. The next thing we need to do is define a prompt. So that prompt, again, maybe let's keep it the same. So write a story about a magic backpack. And now let's get the result. So we essentially need to send over that prompt, right? So we're going to get this prompt and we're going to put it in to the generate content method, and it lives on the Gemini Pro model. So let's grab that model and let's get the generate content method from it, and I'm just going to pass through the prompt. And we're going to have to await this, as this is an async method, so we're going to have to wait for that to come back to us. And once we have that result, we're going to get the response from it. But this is also async, so we need to await it. And let's save the return of this as something. I'm going to save it as response. And once we have that response, I'm going to get the text from it and call it like so, and just save this under text. Okay, so there we go. So let's just console log this text out so we can see what is going on. And I'm just going to call this function. So just like that, let's hit save. And great. So this is the text that comes back. So we've prompted the text, write a story about a magic backpack, and we get a story about a magic backpack. We get the text coming back to us. So in the quaint little town of Willow Creek, amidst rolling hills and whispering willows, there's a curious young girl named Anya. No way, that is me. Little did she know that the ordinary backpack held a secret that would change her life forever. So this is pretty cool. I don't know if that's kind of creepily meant to be based on me or if that is a complete coincidence, but I'm really into this. I will read the story when I have time. Wonderful. I'm really happy with this. Once again, this is the full code that you will need in order to create text prompts. Okay, so now let's look at generating text from text and image input. So this is multimodal. Gemini actually provides a multimodal model called Gemini Pro Vision. So not Gemini Pro, it's Gemini Pro Vision. And we can input both text and images if we want. So let's go ahead and do it. I'm going to show you a super basic example so you can build out your Node.js apps with it. Once again, we're going to be inputting both text and images using the Gemini Pro Vision model with the generate content method from it to generate text input. Okay, great. So this time what I'm going to do, well, let's go ahead and go back to where we started. So I'm just going to move this out here and delete this whole function. So here is where we started off last time. We did say we want the model to be Gemini Pro Vision. So I'm just going to replace that. And now we're going to also require another package that's going to allow us to essentially work with image files a little bit better. It's the package called fs. So fs require fs, which means we need to install it. So once again, I'm going to do npm ifs. In order to install that dependency, you will see it show up in the package JSON. So if you look in here, this is the version of fs that we are using. So just keep that in mind. And once again, revert back to this if you're viewing this in the future and something doesn't seem to be working. Great. Let's move on. Now, we're going to first have to convert local file information to a Google Generative AI part object. And in order to do this, I'm going to write a function. So the function here, I'm going to call it file to generative part. I'm going to pass through two things, a path and a MIME type. Okay, and then we're just going to return an object. I'm going to write inline data, and this is also going to be an object. We're going to pass through some data to it, which essentially we're going to buffer from fs read path, and then we are going to get all of this and append to string base 64. And we're also going to pass through the MIME type. Okay, so whatever we pass through into this function, we're going to put here and here. So that essentially will create a generative part to our files. Now let's go ahead and write our async function again that will run this thing. So async function run, just like so. Once again, we're going to get that model, so define our model in here. And then let's also define our prompt. So const prompt, what's different between these pictures. So just like that. And then let's get both our images. So image parts, we're going to have two. I'm going to use the function we just wrote, and we're going to pass through the file. Okay, so I'm just going to put the files, I'm going to put two in. I'm going to put a picture of a cat. So I'm just going to put it on the same level as the index.js, so we can just write the file name. So there we go, there it is. I'm just going to type it out. So cat.jpg, and this is an image JPEG. And then let's do the other one. So this time I'm just going to drag in another picture. This one is going to be of Rick and Morty. So we have this one, and then we have this one too. Okay, so now I'm also going to write the path to the Rick and Morty file. This is a JPEG file, image JPEG. Okay, again, we can just put through the file names as these files live on the same level as the index.js file. Great. So those are the two images we will be comparing. Now, once again, let's work on getting the result. So const result equals, we're going to await the model. We are using the generate content method, and we're going to pass through an array. So we're going to pass through the prompt and the image part. Okay, this generate content method lives on a different model this time. It lives on the Gemini Pro Vision model. So we can pass through two images along with the prompt. And now once we have that, let's get the response. So response equals result, but we're going to have to await it, and we're going to get the response. And then we're going to get the text. So let's define that text, and we're going to get the response, and we're going to get the text from it like so, and just console log out the text. So great. Now let's run this. So just like so, and ta-da! The first picture is of a cat, and the second picture is of a character from the anime series One Punch Man. I don't know if that's true. I'm pretty sure it's Rick and Morty, so I don't really know what One Punch Man is, but hey, that's close enough. Okay, so great. That is how you would essentially use the generate content method from the Gemini Pro Vision model. Let's move on. So I'm just going to clean this up for the next one. Let's get out this model. I'm just going to put everything back to where it was, and I'm going to delete everything in here so we can start with this, and we don't need that one either anymore. Now let's look at building a multi-turn conversation chatbot. So using Gemini, we can also essentially create chatbots that will essentially take all the history of your chat previously in order to take into context your next questions. To build a multi-turn conversation, so like a chat, we're going to use the Gemini Pro model and initialize the chat by calling start chat, and then use send message to send a new user message, which will also append the message and the response to the chat history. Okay? So there are two possible options for roles associated with this. We're going to have the user, and this is the role which provides the prompt. And we're also going to have the model, which is essentially the role which provides the response. This role can be used when calling start chat with existing history. So let's go ahead and do it. Let's go back to our code. So once again, this is the start point that we have started at throughout this course. I'm going to change the model to be Gemini Pro. So that is now our model. So let's go ahead and write our function. So I'm going to write an async function. Let's call it run. So just like so. And now what we're going to do, well, I'm just going to stick that in here like we have been doing previously. And let's go ahead and essentially start the chat. So I'm going to get the model, and it comes with a method called start chat. So start chat is the method that we're going to use, and we're essentially going to pass through an object. Let's go ahead and also store this as something. So I'm going to save this as the const chat, just like so. And in here, well, we're going to pass through the history. It's going to be an array, as there's going to be multiple objects in here. The first object is going to be of the role user. So let's pretend this is a previous question that we asked. So I'm going to say that as the user, I asked, hello, I have 2 dogs in my house. So less of a question and more of a statement. And then let's also say that the model responded with, great to meet you. What would you like to know? Okay, so that is the history essentially. Now let's also define our message. So let's define our message here. And let's say we want to ask a follow-up question of how many paws are in my house. Okay, so that is a good message. So that is really it. We've got the history, we've got the new question we want to ask. So let's go ahead and get the result, right? So result